For this question, we want to find the domain of the logarithmic function f of x equals log base 5 of negative 8x. So when we're looking for the domain of a logarithmic function, we need to know when a log function is defined. So a log function, log of something, will only be defined if what's inside the log is positive. So this is defined, but log of a negative is undefined, and log of 0 is undefined. So we can sort of understand this a little bit better if we know the meaning of a logarithm. A logarithm means an exponent. So if we have log base 3 of 9, we say we don't know what that equals. So we'll say that equals p. Then that is 3 to what power equals 9? And that's 3 to the second power. So if we have a positive value inside here, this definition of a log being an exponent makes sense. But if you have a negative in there, log base 3 of negative 9, 3 to what power equals negative 9, this doesn't make sense. You can't take a positive number and raise it to a real number and get a negative answer. And the same thing happens with 0. Log base 3 of 0, 3 to what power equals 0. Once again, it's not possible to take a positive number and raise it to a power and get 0. So a log function is only defined for positive values. So if we want to find the domain of this log function, we need what's inside of the logarithm to be positive. So we're going to create an inequality that says negative 8x, that's the expression that we have inside of our log, needs to be positive, which is greater than 0. And we're going to solve that inequality. So I'm going to divide both sides by negative 8. And with inequalities, when you divide by a negative, you need to reverse the inequality symbol to maintain the truth of that inequality. On the left-hand side, the negative 8 divided by negative 8 becomes 1, and 1 times x is x. And on the right, 0 divided by negative 8 is 0. So we can say that all x that is less than 0 are in the domain of this log function. So if we think of that on our real number line, we would mark 0 with an open circle to not include it, and shade all of the values less than 0 to the left of 0. And we usually represent domain in one of two ways. You can represent it in what's called set builder notation. So that's x, all x, such that x is less than 0. Or you can represent it very similar to the number line in interval notation. And you're going to choose a lower bound and an upper bound. That's negative infinity to 0. So we do that to match the shading on the number line. So our domain in interval notation is negative infinity to 0. Thank you for checking out my videos. Have a great day.